Now, in this lecture, we'll find out the ratio of two radii. In the drawing, we have a big circle. Inside this big circle, we have two small circles. The radius of this circle is B, the radius of this circle is A. Our mission is to find out the ratio between the two radii, that is to say, to find the ratio of B over A. In addition, we know that the right triangle ABC is partially located inside the big circle. This angle ABC equals to 90 degrees. Side AB equals to 5 units, side BC equals to 12 units, and AN equals to NC. Our mission is to find out the ratio of B over A. So first of all, we will implement the Pythagoras theorem on the right triangle, triangle ABC. According to the Pythagoras theorem, in the right triangle ABC, AC square equals to AB square plus BC square. It again, right triangle ABC according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore B square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So AC square equals to 25 plus 144 is 169. We take out of this equation, and we get that the square root of 169 is 13. So I found out that the length of the hypotenuse AC of the right triangle ABC equals to 13 units. And we also know that AN equals to NC, that is to say at point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. So AC over 2 is actually 13 over 2 equals to the first half is AN and the second half is NC. Again, AN equals to NC equals to 13 over 2. I found out that the second half NC equals to 13 over 2 units in its length. In the next step, I will present to you rule number 8 and we'll implement rule number 8 in our drawing. We need to rule number 8. The radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. So we have here the right triangle ABC. Angle ABC equals to 90 degrees, side AB equals to units in its length, side BC equals to units in its length, and the length of the hypotenuse AC is C. According to rule number 8, we can find out the radius of this circle is equal to R only by knowing the side lengths of the right triangle ABC that blocks it. That is to say, R will be equal to A plus B minus C over 2. Okay, we can implement rule number 8 in our drawing. Right, in our drawing, we have the right triangle, this right triangle ABC blocks this circle, the radius of this circle is A. According to 1 over 8, the value of A will be equal to AB plus BC minus AC over 2. Okay. So, yeah. This equation is the implementation of 4 over 8 in our drawing. So the radius A equals to AB is 5, BC is 12, and AC is 13 over 2. So 5 plus 12 is 17, minus 13 over 2. 17 minus 13 is 4, and 4 over 2 is 2. So finally we found out that the radius A of the small circle equals to 2 units. You can I know that A equals to 2 units. We define the center of this circle as P, we define the center of this circle as Q, and we define the center of the bigger circle as O. We define the point of tendency of tangent AB with this circle as T. We join points P and T together by a straight line. Point P is the center of the circle, point T is the point of the circle itself, therefore PT is the radius of the circle, is equal to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of the circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle, and therefore tangent BC will be perpendicular to the radius NP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So inside quadrilateral T, B and P, we have 1, 2 free right angles. The sum of right angles is 270 degrees, plus the fourth angle, in total must be equal to 360 degrees, therefore the missing angle here must be equal to 90 degrees. So inside quadrilateral TPBN we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral TPBN as a rectangle. We also know that the opposite sides of a rectangle are equal to each other, that is to say Pn equals to TB. But Pn is 2, therefore TB must be also equal to 2. Likewise Tp equals to Bn. But Tp is 2, therefore Bn must be also equal to 2. So I shall find out that quadrilateral TPBN is not a rectangle but a square, because all of its sides are equal to each other, they are equal to 2 units. So it is given as the equation that BA equals to 5 units. We just right now found out that TB is 2 units, so BA minus BT is TA. Again, BA minus BT is TA. BA is 5, BT is 2, so 5 minus 2 is 3, so 8 equals to 3. Then we have on number 2 that the lengths of 2 tangents from common start point to a circle are equal. We have the common start point A. On the common start point A, we have 2 tangents to the circle, tangent AT, tangent AM. And according to rule number, number 2, they're equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. AN minus AM equals to MN. Again, AN minus AM equals to MN. AN is 13 over 2. And again, AN AM minus AM equals to MN. AM is 13 over 2. Minus AM, that is 3, is equals to MN. And multiply 3 minus 3 by 2 and then divide it by 2 in order to overcome factor of 13 over 2. And you get that 13 over 2 minus 3 times 2 is minus 6 is equals to MN. 13 over 6 is 7, so MN equals to 7 over 2. MN equals to 7 over 2. This line segment MN equals to 7 over 2 units in its length. In the next step, I present to you rule number 7, and we will implement rule number 7 in our drawing. Moving to rule number 7. If a line segment that is drawn from the center of a circle bisects the chord, then the line segment is perpendicular to the chord. We have the center of this circle is here at point O. From the center of this circle, point O, we draw line segment OM that bisects chord AB. That is to say, AM equals to MB. And because of the fact that OM bisect AB, OM will be also perpendicular to AB. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to this rule, rule number 7. So whenever we have from the center of the circle any line segment that bisects a chord, then the line segment must be also perpendicular to the chord. We can implement rule number 7 in our drawing. The center of the biggest circle is here at point O. We join points O and N together by a straight line. So, line segment ON starts from point O, that is the center of the biggest circle. That is the center of the biggest circle. Ends at point N. So ON bisects chord AC. Why? Because AN equals to NC. Therefore, according to rule number 7, line segment ON must be also perpendicular to AC. That is to say, this angle must be equal to 90 degrees, and this angle must be also equal to 90 degrees according to rule number 7. So we can write down that ON is perpendicular to AC according to rule number 7. Point Q is the center of this circle, and here point N is the point of the circle itself. Therefore, Qn must be the radius of this circle that is equal to B units in its length. the radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to Qn, or Qn is perpendicular to AC. So we can write down that Qn, radius Qn, is also perpendicular to tangent AC. And from those two equations, ON is perpendicular to AC and QN is perpendicular to AC, we will derive that point O must be located on the radius Qn. It again, this is point O, that is the center of the biggest circle. It must be located on this radius Qn. Why? Because if point O is not located on Qn, for example, if it is located here, then it will never make an angle of 90 degrees with tangent AC. This angle here in this side will be less than 90 degrees, and the other side will be more than 90 degrees. So only and only if point O is located on the radius Qn, only then ON itself will be perpendicular to AC. Otherwise it will not be perpendicular, therefore point O is located on the radius Qn. If point O is located on the radius Qn, it means that QON is one straight line, QON is one straight line. Define the touching point between this circle and the bigger circle as M, this point as U. We draw tangent with W, that it will be tangent to both circles at point U. This is tangent VW, that is tangent to both circles at point U, to this circle and to the biggest circle. So here, point Q is the center of this circle, point O is the point of the circle itself, therefore QU is the radius of this circle that is drawn to point U. That is the point of tendency of tangent VW with the circle, and therefore tangent VW will be perpendicular to the radius UQ. The radius QU is perpendicular to VW. Likewise, point O is the center of the bigger circle. Point U is the point of the bigger circle itself. This is exactly the definition of a radius. Therefore, OU is the radius of the bigger circle that we defined as X. The radius OU is drawn to the point of tendency, that is to say it is drawn to point U, that is the point of tendency of tangent VW with the bigger circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. So you can write down that OU is also perpendicular to VW. The radius OU is also perpendicular to tangent VW. And from those two statements, QU is perpendicular to VW and OU is perpendicular to VW, we will derive that OQU is one straight line. Okay, OQU is one straight line. That is to say, all the 3 points O, Q and U, they are located on the same straight line. It's very easy to see from a drawing that if one of the points will not be located on this straight line, then it will not create 90 degrees with VW. If point O is here, then OU will not be perpendicular to VW. Or if point Q is here, then QU will not be perpendicular to VW. So all the 3 points O, Q and U must be located on the same straight line. So OQU is one straight line. So we found out that OQU is one straight line and QU all is one straight line. Here, OQU is one straight line and QUO is one straight line. Those two line segments have the same 2 points O and Q. Okay? And we know that 2 points determine a straight line. And because of the fact that they share on the same 2 points, it means that it is the same straight line. This straight line QO belongs to QON, and this the same straight line OQ belongs to OQU. Okay, therefore we can say that OQ is one straight line because 2 points determine a straight line. So it is one straight line. All the 4 points N, O, Q, and U, they are all located on the same straight line. And the straight line is determined by those 2 points, O and Q. Therefore, can derive from all the things that we said here that O, N, O, Q, U is one straight line, and therefore N, U, N, Q, U is one straight line, and therefore NU is also one straight line. NU is a straight line, but NU is a straight line that touches the circle at point N and U. Therefore NU is a chord. Is a chord that passes for point Q, that is the center of the circle. And any chord that passes for the center of the circle must be the diameter of the circle. Therefore NU is the diameter of the circle. Okay. You can write here that NU is the diameter of the circle, or UN, it is the same, is the diameter of the circle. You know that the diameter of a circle is twice as long as the radius, and the radius of this circle is b. Therefore, the diameter UN must be equal to 2b. N equals to 2b. In the next step, we join points O and P together by a straight line. Point O is the center of the bigger circle. Point P is the center of the smaller circle. The smaller circle and the bigger circle touch each other at this point. And you find the touching point as point S. And then I present to you rule number 9 and we'll implement rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together must pass through their touching point. The center of the big circle is 0 at point O, the center of the small circle is 0 at point M, and the straight line that connects their centers together is the straight line OM. According to this rule, rule number 9, the straight line OM must pass through point P, or in other words, OMP is one straight line. Again, OMP is one straight line. You can implement rule number 9 in our drawing. The straight line that connects the centers of the bigger circle and the smaller circle is the straight line OP. And according to rule number 9, because of the fact that the smaller circle and the bigger circle have an internal notch between them at point S, that is to say they are touching each other internally at point S, then we can implement rule number 9 that says that the straight line OP must pass for point S, that is to say OPS is one straight line. Okay, so write it down. According to rule number 9, line segment OPS is one straight line. OPS is one straight line. If OPS is one straight line, it means that SO minus SP equals to PO. Again, SO minus SP equals to PO. So I write it down. It is very clear that if SPO is a straight line, then SO is also a straight line. What is the definition of the straight line SO? The straight line SO starts from point O, that is the center of the bigger circle, and ends at point S, that is the point of the bigger circle itself. This is exactly the definition of a radius. Therefore, SO is the radius of the bigger circle, that is equal to X. We substitute SO in the equation by X. What is the value of SP? Point P is the center of the circle, point S is the point of the circle itself, therefore PS is the radius of the circle, that is equal to 2. So SP equals to 2. In component found out that PO equals to X minus 2 units in its length. This line segment PO equals to X minus 2 units. Okay, so in the next step, we will extend the perpendicular ON by a straight line. And you extend the straight line by a straight line, the result is a straight line, so this is in total a straight line. If you focus on this side of the straight line, point N, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at this side of this straight line at point N? We have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle must be equal to 90 degrees. Tangent AC is tended to the small circle point M. Point M is the point of tendency. We join points P and M together by straight line. Point P is the center of the circle. Point M is the point on the circle itself. Therefore, PM is the radius of the circle that is equal to 2. The radius PM is drawn to the point of tendency. That is to say, it is drawn to point M. That is the point of tendency of tangent AC with this circle. And therefore, tangent AC will be perpendicular to the radius MP. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. In the next step, we will do a construction. We will draw perpendicular on the radius MP at point P. Again, we will draw perpendicular on the radius MP at point P. So actually, this angle equals to 90 degrees according to our construction. We will extend the perpendicular until it touches the extended ON, and we find the touching point is T. So in quadrilateral NMTP we have 1, 2, 3 angles, therefore this fourth angle must be also equal to 90 degrees. So inside quadrilateral PT and M we have 4 right angles, therefore quadrilateral relate quadrilateral PM and T is a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say, PM equals to TN. But PM is 2, therefore TN must be also equal to 2. Likewise, in rectangle MNTP, MN equals to PT. But MN equals to 7 over 2, therefore PT must be also equal to 7 over 2. In the next step, we define the length of line segment NO as H, and we implement the Pythagoras theorem on the right green triangle, triangle PTO. So call it the right triangle PTO in a new page, and we implement on this the Pythagoras theorem. The hypotenuse PO equals to x minus 2. That's what we already found out. This is the right triangle POT. My PT is the version for Pythagoras theorem. We just like now found out that PT equals to 7 over 2. And what is the length of OT? OT equals to ON plus NT. That is to say, OT equals to ON, that is H, plus NT, that is 2. So in total, OT equals to H plus 2. Now we implement on this right triangle POT the Pythagoras theorem. According to the Pythagoras theorem, we get that PO square equals to PT square plus OT square. So PO equals to x minus 2, therefore PO square equals to x minus 2 squared. And it is equals to PT squared. PT is 7 over 2, therefore PT squared is 7 over 2 squared, that is 49 over 4. Plus OT squared. OT is h plus 2, therefore OT squared is h plus 2 squared. Here we'll open the brackets on both sides of the equation, and we'll get that x minus 2 squared equals to x squared plus 2 squared, that is 4, minus 4x, that is equals to 49 over 4, plus h plus 2 squared equals to h squared, plus 2 squared, that is 4, plus 4h. So, in the next step, we join points O and C together by a straight line. What is the definition of the straight line OC? The straight line OC starts from point O, that is the center of the biggest circle, and then at point C, that is the point on the biggest circle itself. Therefore OC is the radius of the biggest circle, that is equal to x. According to our definition, ON equals to h. And in the beginning of the lecture, we found out that NC equals to 13 over 2. So I copy the right triangle NOC in a new page, and we'll implement on it the Pythagoras theorem. Actually, this is the right triangle ONC that I copied from the original drawing. OC equals to x, ON equals to h, and NC equals to 13 over 2. Now we will implement on this right triangle ONC the Pythagoras theorem. According to the Pythagoras theorem, OC squared equals to ON squared plus NC squared. OC is x, therefore OC squared is x squared, and it is equals to ON squared. ON is h, therefore ON squared is h squared, plus NC squared. NC is 13 over 2, therefore NC squared is 13 over 2 squared. It is 169 over 4. So in conclusion, we found out that x squared equals to h squared plus 169 over 4. Therefore, we can actually substitute x squared here in this equation by h squared plus 169 over 4. We'll do it now, and we'll get that x squared is h squared plus 169 over 4 plus 4 minus 4x equals to 49 over 4 plus h squared plus 4 plus 4h. So here we have h squared both sides of the equation, so h squared will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled. And we left only with 169 over 4 minus 4x, that is equals to 49 over 4 plus 4h. Okay. Here we'll subtract 49 over 4 from this equation, and we get that 169 minus 49 over 4 minus 4x equals to 4h. So here we add 4x to this equation, and we get that 169 minus 49 is 120 over 4 equals to 4x plus 4h. So here we take 4 as a current factor from those two expressions. Inside the brackets we left only with 4 times x plus h equals to 120 over 4 is 30. So in conclusion found out that equals to 4 times x plus h. Here we divide this equation by 2, and we get that 30 over 2 is 15, and 4 over 2 is 2. So in conclusion found out that 15 equals to 2 times x plus h. Here we'll divide this equation by 2, and we get that x plus h equals to 15 over 2. Okay, we found out that x plus h equals to 15 over 2. What is the value of un? Un equals to uo plus on. So un equals to uo, that is x, plus on, that is h. So in total un equals to x plus h. So you can argue that un equals to x plus h for one side, and for the other side we've already found out that un equals to 2b. Un equals to 2b. So we're going to get that un equals to 2b. And from those two equations, un equals to x plus h and un equals to 2b, we derive that 2b equals to x plus h But we already found out that x plus h it is also equals to 15 over 2, so we can write there that x plus h equals to 15 over 2. And from this equation 2b equals to x plus h equals to 15 over 2, we derive that 2b equals to 15 over 2. 2b equals to 15 over 2. Here we divide this equation by 2, and finally we get that b equals to 15 over 2 over 2 is 15 over 4. So we found out that b equals to 15 over 4. That is to say the radius of this circle b equals to 15 over 4 units in Israel. And we already found out that the radius of this circle, the small circle A, equals to 2 units. A equals to 2. And what is the ratio of B over A? B over A equals to B, that is 15 over 4, over 8, that is 2. So 15 over 4 over 2 is 15 over 8. In conclusion, found out that the ratio B over A equals to either 15 over 8, or in terms of numbers, it is equals to 1.875 without units. And that is the answer to our question. Okay. The ratio B over 8, it is the ratio between the radius of this circle and the radius of this circle, equals to either 15 over 8, or in terms of numbers, it is equals to 1.875. Without units. In the next step, I will summarize the lecture. So in this lecture I found out the ratio between the radius of this circle that is B to the radius of this circle that is A, or the ratio of B over A. So in the drawing we have the big circle. Inside this big circle we have two small circles. The radius of this circle is B, the radius of this circle is A. Our mission is to find out the ratio of B over A. We also know that inside the big circle we have the right angle ABC that is actually partially located inside the big circle. This angle ABC equals to 90 degrees. The length of side AB is 5 units, side BC equals to 12 units in its length. And we also know that AN equals to NC. Our mission is to find out the ratio of B over A. That is the ratio between the two radii. So first of all, we implemented the Pythagoras theorem and the right angle ABC. And the right angle ABC according to the Pythagoras theorem, AC square equals to AB square plus BC square. I'll repeat again. The right angle ABC according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 square, that is 25. Plus BC square. BC is 12, therefore BC square is 12 square, that is 144. So in conclusion, found out that AC square equals to 25 plus 144, that is 169. So AC square equals to 169, we took out all of this equation, and finally found out that AC, the length of the hypotenuse AC is equals to 13. With the length of this, AC equals to 13 units. Therefore, AC equals to 13 units in length. Okay, and here AN equals to NC. So at point N, the hypotenuse AC is bisected into two halves. The first half is AN, the second half is NC. So you can write it that AC over 2, that is 13 over 2, equals to the first half, that is AN, and the second half is NC. So AN equals to NC equals to 13 over 2. Here, the second half NC equals to 13 over 2. Then I presented to you rule number 8 and implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R, A plus B minus C over 2. So here the right triangle ABC, the length of AB is A, the length of side BC is B, and side AC equals to 3 units in its length. This angle ABC equals to 90 degrees. So here, according to rule number 8, we can know what is the length of the radius R only by knowing the side lengths of the right triangle that blocks this circle. That is to say, R will be equal to A plus B minus C over 2. We can implement this rule number 8 in our drawing, because in our drawing we have the right triangle ABC. This angle ABC equals to 90 degrees. This right triangle blocks the circle that its radius is A. So according to rule number 8, we get that the radius A will be equal to AB plus BC minus AC over 2. Repeat again. According to rule number 8, the radius A of the circle that is blocked by the right triangle ABC will be equal to AB plus BC minus AC over 2. AB is 5, BC is 12, and AC is 13, all divided by 2. 5 plus 12 is 17, 17 minus 13 is 4, and 4 over 2 is 2. So finally we found out that the radius A of this circle equals to 2 units. Then we define the center of this circle as P, we define the center of this circle as Q, and we define the center of the biggest circle as O. We define the point of tendency of tangent AB with this circle as T. We join points P and T together by a straight line. Point P is the center of the circle, point T is the point of the circle itself. Therefore, PT is the radius of the circle, that is equal to 2 units. We have the radius PT that is drawn to point T, that is the point of tendency of tangent AB with this circle, and whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Then we define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of the circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. Therefore, tangent BC will be perpendicular to the radius MP, that is to say, this angle will be equal to 90 degrees, and this angle will also equal to 90 degrees. So in quadrilateral PTBN, we have 1, 2 free right angles. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So quadrilateral TPBN that has 4 right angles, we relate to it as a right angle. We know the opposite sides of a right angle are equal to each other. That is to say, TB equals to PN. But TB is 2, therefore PN must be also equal to 2. Likewise, in right angle TPBN, TP must be equal to BN, but TP is 2, therefore BN must be also equal to 2. So we found out finally that quadrilateral TPBN is not a rectangle but a square because all of its sides are equal to each other. So we found out that TB equals to 2 and AB equals to 5 according to what is given as the equation. Therefore AB minus TB is 80, 5 minus 2 is 3, so 80 is 3. We have rule number 2 that the lengths of two tangents from common standpoint to a circle are equal. For the common standpoint point A, we have two tangents to the circle, tangent AT and tangent AM, and according to rule number 2, they are equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We already found out that AN equals to 13 over 2, AM equals to 3, therefore AN minus AM equals to MN. Let's it again. AN minus AM equals to NM. AN is 13 over 2, AM is 3. Here we multiply minus 3 by 2 and then we divide it by 2 in order to return factor with 13 over 2. So 13 over 2 minus 3 times 2 is minus 6. So 13 minus 6 is 7. So we probably found out that NM or MN equals to 7 over 2 units in itself. This 9/7 MN equals to 7 over 2 units in its length. In the next step, I presented to you rule number 7 and implemented rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects the chord, then the line segment is perpendicular to the chord. The center of the circle is here at point O. From point O, we draw line segment OM on AB that bisects AB. That is to say, AM equals to MB. So when you draw from the center of the circle any line segment that bisects the chord, it will be also perpendicular to the chord. Because OM bisect chord AB, OM will be also perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees, according to rule number 7. So we can actually implement rule number 7 in our drawing. In our drawing, we have we join points O and N together by a straight line. O and bisect chord AC. O is the center of the bigger circle and line segment ON bisects chord AC. That is to say, AN equals to AC, therefore line segment ON must be also perpendicular to AC. So ON is perpendicular to AC. So we can write here that ON is perpendicular to AC. Then here point Q is the center of this circle, point N is the point of the circle itself, therefore QN is the radius of this circle. The radius QN is drawn to point N, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius QN. So you can write also that QN is also perpendicular to AC. Yeah. QN is also perpendicular to AC. From those two equations, ON is perpendicular to AC and QN is perpendicular to AC. We will derive that point O must be located on QN. This point O, that is the center of the bigger circle, must be located on the radius QN. Okay. If Q is located on the radius QN, it means that QON is one straight line. This line segment QON is one straight line. Likewise, we define the point of tendency of this circle with the bigger circle as Q. Then we draw tangent VW, that is tangent at point Q to both circles, to this circle and to the bigger circle. Okay. So here point Q is the center of the circle, point Q is the point of the circle itself, therefore QU is the radius of this circle. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius QU. If VW is perpendicular to QU, it means that you can write down that the radius QU is perpendicular to tangent VW. The radius QU is perpendicular to tangent VW. Likewise, point O is the center of the biggest circle. Point U is the point of the biggest circle itself. Therefore, OU is the radius of the biggest circle. The radius OU is 1 to point U, that is the point of tendency. Tangent VW is the circle, and whenever the radius that is 1 to the point of tendency, then tangent VW will be perpendicular to the radius UO. So you can write here that OU is also perpendicular to VW, and from those two equations, QU is perpendicular to VW and OU is perpendicular to VW, we derive that all the 3 points O, Q, and U, they are one straight line. Those 3 points O, Q, and U, they are all located on the same straight line, or OQU is one straight line. Actually, OQU must be one straight line, otherwise, if point Q will not be located on OU, for example, if it is located here, then it will never make angle of 90 degrees with VW. The same thing is true if this point O, if it is not located on this straight line Q, if it is located here, then it will never create an angle of 90 degrees with VW. Therefore, all the 3 points of QU must be located on the same straight line. So here, so from one side, OQU is one straight line. But we have already found out that QUN is one straight line. So those two line segments, QON and OQU, share 2 points, Q and O. They have the same 2 points, Q and O. And you know that 2 points determine a straight line. 2 points determine a straight line. So if UQO contains the straight line OQ and OQN also contains the straight line QO, it means that they contain the same straight line, they are one straight line. Okay? Both those two line segments QON and OQU contain the same straight line QO. It means that they are the same straight line. Why? Because those 2 points determine a straight line. Therefore, they are one straight line. So all the 4 points N, O, Q, and U, they are all located on the same straight line. Therefore, NQU is also a straight line, and NU is also a straight line. But NU is a straight line that touches the second point N and U, therefore NU is a chord. NU is a chord that passes for point Q that is the center of the circle, and any chord that passes for the center of the circle must be the diameter of the circle. Therefore NU or UN is the diameter of the circle. And the diameter of any circle is twice as long as the radius. Therefore UN is the diameter of the circle that is equal to 2b. Okay, UN equals to 2b. Okay, then I presented to you all number 9 and implemented all number 9 in our drawing. According to all number 9, if 2 circles touch each other internally, then the straight line that connects their centers together must pass for their touching point. The center of the big circle is here at point O, the center of this small circle is point M. The straight line that connects their centers together is the straight line OM, and according to all this whole rule number 9, the straight line OM must pass for point P. That is to say, OMP is one straight line. So those 2 circles have an internal notch between them at point P. You can implement rule number 9 in our drawing. Why? Because in our drawing, the smallest circle and the biggest circle touch each other internally at point S. This is their touching point. So they have an internal notch between them. The center of the biggest circle is here at point O, the center of the smallest circle is here at point P. The straight line that connects here that goes together is the straight line OP. And according to rule number 9, the straight line OP must pass through the touching point S. That is to say, OPS is one straight line. OPS is one straight line. It again. OPS is one straight line. According to rule number 9, OPS is one straight line. So if OPS is one straight line, it means that SO is also one straight line, and SO once SP equals to PO. Again, SO once SP equals to PO. What is the definition of SO? SO starts from point O, that is the center of the biggest circle, and then the point S, that is the point of the biggest circle itself. Therefore, OS is the radius of the biggest circle, that is equal to X. So you can substitute OS or SO by X. What is the definition of SP? Again, SO minus SP equals to PO. SO minus SP equals to PO. What is the definition of SP? P is the center of the circle, S is the point of the circle itself, so PS is the radius of the circle, that is equal to 2. So we can substitute PS or SP by 2, and in total we found out that PO equals to X minus 2. This line segment PO equals to X minus 2. Then we extended the perpendicular ON by a straight line, and we focused on this side of the straight line ON, the extended ON, the sum of the angles, and this side of the extended ON point N must be equal to 180 degrees according to the rule that the sum of the angles from one side of the straight line is equal to 180 degrees. So which angles we have at this side of the straight line at point N? We have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. And we know that AC is perpendicular to this circle point M. Point M is the point of tendency. We join points P and M together by a straight line. Point P is the center of the circle, point M is the point of the circle itself, therefore PM is the radius of the circle, is equal to 2. The radius PM is the radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle, and therefore AC is perpendicular to the radius MP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then we did the construction. We draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. That is to say, this angle equals to 90 degrees according to our construction. Then we extended the perpendicular PT until it touches the extended ON at point T. This way we created quadrilateral PT and M. In quadrilateral PT and M we have 1, 2 free right angles, therefore the fourth angle must be equal to 90 degrees. Therefore quadrilateral PT and N that has 4 right angles, we relate to it as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, PM equals to Tn, but PM is 2, therefore Tn must be also equal to 2. Likewise, Mn must be equal to PT in rectangle PM and T, but Mn is 7 over 2, therefore PT must be also equal to 7 over 2. Then we defined NO as H. And then I copied the right triangle POT in a new page, the right triangle POT in a new page, and we implemented on it the Pythagoras theorem. This is the right triangle POT that I copied from the original drawing. The hypotenuse PO equals to X minus 2 according to what we already found out. We just right now found out that PT equals to 7 over 2. And here OT equals to ON plus NT. That is to say, OT equals to ON, that is H, plus NT, that is 2. So in total, OT equals to H plus 2. OT equals to H plus 2. Now we can implement in this right triangle POT the Pythagoras theorem. According to the Pythagoras theorem, in the right triangle POT, PO square equals to PT square plus CO square. Again, PO square equals to PT square plus CO square. So PO square, PO is X minus 2, therefore PO square is X minus 2 squared, and it equals to PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, plus TO square. TO is H plus 2, therefore TO square is H plus 2 square. Then open the brackets on both sides of the equation and found out that x plus 2 squared equals to x squared plus 2 squared, that is 4 minus 4x, and it is equals to 49 over 4 plus h plus 2 squared equals to h squared plus 2 squared, that is 4 plus 4h. Okay, then we join points O and C together by a straight line. OC is the radius of the biggest circle that is equal to x, ON is h, and NC is 13 over 2. So I copy the right, and this angle equals 90 degrees according to rule number 7. Then I copy the right triangle ONC in the new equation to be implemented on it, the Pythagoras theorem. The right triangle ONC, according to the Pythagoras theorem, OC squared equals to ON squared plus NC squared. OC is x, therefore OC squared is x squared, and it is equals to ON squared. ON is h, therefore ON squared is h squared, plus NC squared. NC is 13 over 2, therefore NC squared is 13 over 2 squared, that is 169 over 4. So in conclusion, found out that x squared equals to h squared plus 169 over 4. Now we can substitute x squared in this equation here by h squared plus 169 over 4. H squared plus 169 over 4. We actually did it, and we found out that here we have x squared, that is h squared plus 169 over 4 plus 4 minus 4x equals to 49 plus h squared plus 4 plus 4h. Okay, so here we have h squared on both sides of the equation, so h squared will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled. And we have to leave 169 over 4 minus 4x, that is equals to 49 over 4 plus 4h. Here we subtracted 49 over 4 from this equation and found out that 169 minus 49 over 4 minus 4x equals to 4h. We added 4x to this equation and found out that 169 minus 49 it is 120, so in total this expression equals to 120 over 4, and it is equal to 4x plus 4h. Here we took 4 as a common factor from those two expressions, so inside the brackets we left only with x plus h. So in total we found out that 120 over 4 is 30, so 30 equals to 4 times x plus h. Here we divided the equation by 2 and found out that 30 over 2 is 15 and 4 over 2 is 2. So in total we found out that 15 equals to 2 times x plus h. Here we divided the equation by 2 and finally found out that x plus h equals to 15 over 2. So what is the length of this line segment UN? UN equals to UO plus ON. That is to say UN equals to UO, that is the radius of the biggest circle, that is x, plus ON, that is h. So in total UN equals to x plus h. From one side we found out that UN equals to x plus h, but from the other side, we have already found out that UN equals to 2b. UN is the diameter of the circle, it is equal to 2b. So I can write here that UN equals to 2b, and from those two equations, UN equals to x plus h and UN equals to 2b, we will derive that 2b equals to x plus h. 2b equals to x plus h, but we already found out that x plus h, it is also equals to 15 over 2, so I can write here that x plus h equals to 15 over 2, and from this equation 2b equals to x plus h equals to 15 over 2, we will derive that 2b equals to 15 over 2, 2b equals to 15 over 2, 2b equals to 15 over 2, here we divided this equation by 2, and finally found out that b equals to 15 over 2 over 2 is 15 over 4. So b, the radius of this circle b equals to 15 over 4, and we have already found out that the radius of this circle a equals to 2. And finally found out that b over a equals to b, that is 15 over 4, over 8, it is 2. 15 over 4 over 2 is 15 over 8. So in conclusion found out that the ratio between the two radii b over a equals to either 15 over 8, or in terms of numbers it is equals to 1.875 without units. Again, I repeat again, the ratio between the radius of this circle and the radius of this circle, that is to say b over a equals to either 15 over 8, or in terms of numbers it is equal to 1.875 without units. Okay, thank you very much.